Hey guys, my name is Pat Peters. Today I'm going to talk about the web service Shodan and how we can combine Shodan with the open source tool OnionScan to find vulnerabilities that can expose hidden services on the Onion router, or Tor for short. Now, on many TV crime shows and movies, you hear this foreboding part of the internet where secrecy and the underground reign supreme, called the dark web. This part of the internet was originally, back years ago, created by websites that opted out of being scanned and indexed by the original search engines, by Google in its infancy. It has now since morphed into a community that actively seeks to remain anonymous in their existence. From journalists and activists trying to remain anonymous in their reporting, to companies keeping trade secrets privately available while in development, to even drug cartels in the Silk Road, privacy is the primary element that brings people to the dark web. Unfortunately for these privacy seekers, often crucial elements that are used to set up these anonymous servers can be exposed during the setup process, which could risk leaking personal information about the anonymous service for all users to see. Today, we'll take a look at one tool called OnionScan that helps highlight these exposed data parts for good or bad and tells users how to patch these vulnerabilities. Now, Shodan we're not going to spend a ton of time on because we've actually already talked about this in class. It's a search engine for internet-connected devices. Now, how it works, it actually sends a single packet internet-wide web survey that hits all of the addresses in the IPv4 address space in a big blast, and checks the banners, ports, and other services that are returned from this survey that's sent out. Now, the data that can be gathered in these surveys can include open ports on servers, hosted web services, webcams. It's kind of how Shodan was originally first known, was that you can search for webcams, and a lot of the times end up finding ones that have the default password set to it. SCADA system controls, any of the game server configs. I myself have used this a couple times, helping out my little brothers find some Minecraft game servers that they were able to actually hop on. So it's a very useful tool that's used quite extensively in the public. Now, the Tor project is actually a little bit different. It's actually, as I said earlier, it stands for the Onion Router, and it's a network of anonymous devices that relay encrypted traffic at random relay points. So that's where the onion piece of the Onion Router comes in, is each packet that's sent is actually encrypted in several different layers of encryption, and each layer actually points to the next relay that it's actually supposed to go to. And so the theory behind this is that it ensures if anyone successfully decrypted all the traffic that was passing through a relay, since each layer is stripped away and a new layer of encryption is put over the top of it when it hits a relay, there's really no way you'd be able to figure out who the original source of the packet was and what the final destination was. So sites that are hosted on Tor typically end in .onion addresses. That's the other part of the Onion router. And these sorts of services are only accessible via Tor-accessible browsers. So speaking of those .onion hidden services, a .onion service, as I said, ends in the address space and then .onion. When configured correctly, a .onion address is an anonymous hidden service. It's very difficult to access any information about the provider or any users that are currently accessing it. Unfortunately, server hardening these Onion services anonymously can be really tricky. That's mainly because a lot of the setup pieces that are actually put in during this process can be very unique and can be uniquely identifiable to someone who might have used the same process on a different machine. So items such as PGP encryption keys, SSH fingerprints, Bitcoin addresses, or any other coin address, or web server configs that are mishandled and exposed can all lead someone to actually identifying one of these anonymous services. Probably one of the most common issues that actually comes up is if someone uses the Apache web service, or uses Apache, the software, for hosting a web service. There is a mod status actual module that loads in the beginning that displays all the necessary information about the service, like its publicly accessible IP address, what version of Apache is currently running, and if there are any updates. Unfortunately, if you don't actually close this module down so it doesn't load, that can expose a lot of personal information about someone who's hosting this anonymous service. That's probably one of the most popular vulnerabilities that comes up. So defensively, you want to avoid exposing these types of unique identifiers if you set up hidden services on Tor, because you don't want to be identified. But offensively, if you're part of, say, like an open source investigation or OSINT investigation, if you could connect a unique identifier of a hidden service to a public host or service, like through Shodan, you can identify an anonymous service. Now, not quite beyond a shadow of a doubt, but you can get a certain road path that that'll actually lead you to hopefully identifying an anonymous service like that. So without further ado, let's start looking at the tools. Okay, so the first tool that we're actually using tonight is OnionScan. This is the GitHub repository for it. Now, OnionScan is actually put together in the Go language, so there are some dependencies that you need to install if you want to use this. And thankfully, this project is very well documented as far as how to get it installed and get it set up. I went through all the installation instructions here and had no problems. Once you get it installed, I actually have a virtual machine that it's installed on currently. All you have to do is specify that you're going to be using a specific version of Go. So in this case, I'm using 1.9. And then you can actually run the command. So this is the command, OnionScan. There's a ton of options that if I were to just hit OnionScan alone, it would actually tell me. In this case, I want a JSON report, and I want the full report, not a simple report. And then you specify an actual address that you want to scan. So this is the .onion address. This will come up a little bit later, so I won't explain it quite yet. But I'm going to let that go. And that normally takes a couple minutes, so I'm going to let that run in the background. So I can do that sort of command for, you know, one address or a couple, or if I'm in a more of an open source investigation sort of atmosphere, I might end up needing to do that quite a bit. So I actually went through this, where I first found out about OnionScan, and this process is from this tutorial that I found on automating OSINT, which is all about using Python to automate this OnionScan process with Shodan. Here's the link to the actual tutorial, and also there's a GitHub repository for the code that's actually hosted on this tutorial too. This one isn't quite as well maintained. I actually had to make some changes in order to get this working, but I was able to actually download the file, make a few changes just to account for the new version of Python, and get it working. So there's two files. This is the Onion Runner file. You feed it an actual text file list of valid onions. That's actually this list here that I have. This is just all onion addresses. And basically, without getting too deep into the weeds on this, there's a couple of functions that run the onion scan. You can see it's actually building the command that it ends up running for a given onion that it picks up from the list. If it ends up getting any sort of data within 5 minutes, I have a timer set automatically for 5 minutes because otherwise it just sits and hangs. If after 5 minutes it gets any data, there's another function that actually processes the results where it takes the results and pipes it into a JSON file. Otherwise, if it doesn't get anything, it still actually pipes into a JSON file, but it just returns with basically no vulnerabilities. So this is the first file that's actually running that automatically. And it looks like actually that command that I hit earlier finished up. There's that's all the data that gets returned to it. Part of what's so hairy about that is the actual address that I was doing actually had a PGP key that was attached to it. So you see that's actually the key that's there, and also an SSH fingerprint. So that's interesting. But as you can see from this green cursor down here, it actually hung up after after receiving those results. So that's part of what that Python script does, is it automatically kills the process after 5 minutes and restarts a new Tor identity and runs the same command. So I actually have that still running on my VM. This is actually the process. I've been running it for a couple weeks now, and it's up to scan 7,060 of those onion addresses. There's quite a few that are there. And the nice thing is, if it picks up any additional onion addresses that are attached to a specific page, then it actually stores those into that file. So this list actually started with 4,000 onions, and it's actually grown to 18,000 just from picking them up in the scans. So that's interesting. So Once it finishes scanning for a site and saving the JSON file, it saves it in this folder that's OnionScan results. These are all the JSON files. Now, once again, I could go through this, individually, look for any sort of SSH fingerprints and search on Shodan for them, or I could use a Python script actually to do the exact same thing. So that's what this Python script does. It's looking for any JSON files that are in that OnionScan results folder, and it actually imports the Shodan module, loads each address individually, and actually hits the Shodan API. You do have to sign up for a free account so that you can get a key. But once I have the key and everything's there, I actually search the Shodan API in the exact same way that you could actually search on the main host page, and I'll show that here in a sec. Then as it goes through, if it runs into results, it actually says that we have a hit. If it doesn't run into a result with one of the SSH keys, it says no hits. So that I'll actually show you real quick. Oh, I had to clear that. So here's the actual Python script in effect. Okay. So what it brought up here, these are all the SSH fingerprints that it actually picked up from scanning all the sites. So that's just to give you a sense of how kind of sparse this can be. I was searching over 7,000 sites, and it brought up less than maybe, I think, what was that, like 30 SSH fingerprints total. So that's that's really telling as far as it's a kind of a needle in a haystack sort of event. And so then what's happening here is it grabs each key individually and searches Shodan, you can see. These cases, it had no hits for these fingerprints that are here. Had a hit actually for this one, for this IP address. Same with this one. And looks like we ran into an error based off of that key. I think it's an invalid fingerprint based off of how long it is. And that's it. It just finished hitting all or searching all of those keys in Shodan. You have to space them out, like in the actual script. I have it set to sleep for about 5 seconds. That's why you notice it would pause for a bit and then it would actually search, because otherwise you end up hitting the limit of search attempts in a given time frame. So let's take one of these and see what's going on. So this is actually, this will look a little bit familiar. This was actually the onion address that we scanned earlier at the beginning of this demonstration, and it looks like it actually resolved to an IP address, actually 2 IP addresses, but I'm going to search this one because I actually know this one. So if I search in Shodan for this IP address, I could also put in the actual SSH fingerprint and it would show up. And looks like this is the Russian Federation. Ooh, fun. And this is a site that actually has the vulnerabilities listed that were also picked up in Shodan. And actually something that's a little bit interesting. Oh, this actually looks like they've actually changed this a bit since the last time I checked this, because I checked this. Oh yeah, you can even see the last update was made on the 26th. That's today for me at 8:15. So it does look like they've actually changed this considerably. But we could see there's OpenSSH and the key. Notice this fingerprint that's here. I'm just going to do the first 4 characters. OC8D7710. If I bring up this one. So the hit was right here, and if you look at the first 4, OC8D7710, I could match up the whole rest of them, but there is our SSH fingerprint that links this public service to this private, supposedly anonymous onion address. So that is the whole process in a nutshell. And that's basically about it. Thank you very much. Hope you enjoyed the presentation.